Feel free to interrupt at any point. I'll take questions at the end too. I think I probably have 563 slides. No, just 22. One of which is just my name. So not an awful lot of slides here. I'll do a little bit of a demo in Visual Studio, give you a little walkthrough of a couple of the concepts and that kind of stuff. Roughly out of the talk, I was going to talk a little bit about the why microservices are important. Talk a little bit about the what microservices are, and a little bit about the how, I guess, the practice of microservices is, and maybe give a couple like pointers in terms of, I hesitate to say best practice. I don't think I usually try and stay away from that word entirely. Every project's different, but give you some tips on things that we've run into and things that might save you some time when you're on a project that needs these. I'll give you a quick demo. I'll show a little bit of probably mostly I'm guessing the sort of the container environment foremost, because that's kind of the thing that most developers, I would say, are most challenged learning, right? The actual microservices piece is probably, okay, that's sort of a nice evolutionary step from where we are with API design and our normal work on web type projects. But and so it's more of I'd say an architecture exercise, right? How we design the code there. That's skills that we're fairly familiar with in terms of how we implement them. The container side is a little bit new stuff. So, so I'll show a little bit of that. I'm going to use the Docker for Windows attachments here. You'll see that stuff as we go through it. That's sort of how you emulate what a container environment is going to look like. Our real world scenario, we actually deploy to both what we call PKS, which is a VMware, used to be called Tanzu environment, which is a full Kubernetes environment. We have a Michigan and a Virginia installation, I don't know what set of pods, I guess, environment. That's fairly large, and then we have sort of a low tech form factor. We're in the retail industry, so we have the in-store implementation as well. It uses a Kubernetes deployment called Rancher, and then we'll have some time for questions and that kind of stuff afterwards here. So, okay, so let's start with why. Let's start with the why here. So. This picture actually is from one of the more famous blogs that I refer to at the end, but I guess I'd say that microservices sort of grew out of a confluence of a couple different things. One, the idea of large systems being really hard to deal with, right? And so I would say a lot of teams, we'll say 5-10 years ago, we're starting to deal with either really large monolithic applications, or they were dealing with applications that had a lot of real-time data that was going through them. So this idea of a streaming platform of various sorts, you'll see from some of the examples, oh, that makes sense, right? They're streaming data. It's not necessarily all the same type of data, but the idea that you have a very asymmetrical flow of data, you want to apply certain new types of functionality to that data, such as stream processing and things like that, makes them look like IoT systems effectively, right? So if on the greenfield projects, you had those type, and then you also had these legacy projects that were basically becoming bears to deploy. So microservices in some way an answer to that. And in general, when we think about systems engineering, we know, having worked on projects, systems grow over time. Either you are going to be adding new features, and probably the toughest ones to add are the ones that we really didn't conceptualize. We didn't have, maybe we didn't even have, certainly didn't have requirement statements, but didn't have any idea that this application would be used in that context over there, and until maybe a year or two or however far into the project, right? And so adding new features is important. And I guess I've seen that on the whole program side as well, where one application does so well that it ends up eating up another application entirely. The business itself may change. You may have different types of users over time, and they may drive other types of what I would consider business change in the intent of the system, right? And then the interesting confluence there with the IoT systems is that a lot of the IoT systems, I would say, when we think of like, give you a couple examples, like a social network type solution like a Facebook, a autonomous vehicle type scenario, right? Which is, I would say, a true IoT one. They might have started out as fun little prototypes, but then we realized, well, wait a second, there are some characteristics of these systems that are very difficult for us to square with our traditional, either building bottom up, building kind of like a prototype or an MVP, and then stitching it together and then growing it into the system that it should become, or being able to deal with real-time flows of data. They don't tend to lend themselves to what I would consider quality attributes, cross-cutting concerns. Probably the two most important ones I put on here. One is availability, and the other one's performance. And so what we found with like small grassroots type efforts, availability was just a bridge too far, right? That's too hard to build in after the fact because there are just so many failure modes at that point when different like small programs or services have been bolted together. The performance side is also interesting, and I'll talk about a little bit on the design side a little bit later about how do we deal with that one. So traditionally, how have we dealt with some of these challenges? We go, okay, if we know the system has some need for scale, meaning lots of users, lots of data, something like that. How we deal with performance, how we deal with availability. So I'm going to limit it to just those three attributes of our system here. On the scale side, we scale up or we scale out, right? We try and do these sorts of things. Then we have gone to maybe public cloud or something like that, which might represent a scalable resource. You can start seeing some of the problems that we have with those sorts of answers, right? Every one of those has sort of some reasons where it's not necessarily applicable. On the performance side, we might optimize around a single calculation sort of thread or single compute algorithm that we're doing there. Okay, that's one way to do it, right? It's sort of starting with a prototype. And then the tough part is it gets worse and worse as we add security, as we add other services around that core compute and things like that, right? So that was kind of, okay, well, our traditional systems engineering approaches don't work as well. What we could do, some folks are sort of playing around with, okay, we can always unroll parts of it, right? And by that, I mean, if you have a big system, I'm not gonna mention who it was, they're a loan processor here in Michigan, and there are a lot of them. It's kind of funny because I'm like, I didn't realize how many of them there are in Michigan. I don't know if it's a thing that we do, but this was one of them, and they had a legacy application. They're like, okay, we're just going to do what's called the strangler pattern, and we're going to just, take a bite off little chunks of this application. Eventually, it'll be rebuilt, right? And that has its own sort of pieces with how we deal with legacy tech debt over time that make it really, really complicated, right? And your performance kind of drops off for a certain amount of time before you get to that promised land that you've had the whole app rebuilt, right? So there potentially it takes a long time to get there. Then the other academic solution would be to actually develop a new algorithm, right? And just change the problem into making it simpler. That turns out to require a lot of horsepower in a lot of cases, mental horsepower. So coming up with these new ideas is, you kind of have to wait for that moment of brilliance to happen and go, oh, I could solve this a totally different way, right? And So that's kind of a little trickier thing to sort of plan for. On the availability side, what's our traditional technique for that? Well, if we want a highly available system, we're going to duplicate everything, right? We'll replicate and have 2 network routers. We'll have them cross-coupled with our compute infrastructure. We'll have that cross-coupled with 2 different redundant data storage pieces, and then we're just going to test the heck out of it, right? Or, we can always put a facade around it and try and hide it. That's actually one of the early SOA examples was Expedia. And Expedia is a travel site. Their back end, so here the BFF pattern, right? Back end for the front end. They experimented with this probably back in I'd say the early 2000s. Their back end was the Sabre system, which is written by American Airlines to do airline bookings, right? And so they wrapped that in web services and basically took that whole back end, which was a mainframe, and I don't think they've changed it yet, but they put a facade on the front of it to make it look available, even though there are outages and things like that that happen for that system. So these are sort of our traditional ways of solving this. Okay. Tough part is each one of these has some drawbacks, and so scale up or even scale out, you go, okay, to have multiple nodes, I have to have more hardware. Hardware costs money, right? Moving to the cloud sort of helps, kind of, except that when I really need a lot of hardware, I still have to pay for that hardware, right? Integrations outside of our system always have been kind of weird. We can't really do design patterns because that other system is a black box to us, right? So when we are, sort of our fallback is, okay, I'm just gonna write one big giant app that's going to deal with this, somehow, right? And all the code that I need to work around that other system has to be in my box. So you have certain design patterns that we see in the code, like circuit breaker, store and forward, different types of event detection, health checks and things like that of the other system to go, okay, can I actually process something through you right now? Sort of keep going down the list here, monolithic systems, there's a certain amount of operational baggage that we have with each of them. Big systems tend to have, we'll say availability problems from the weirdest sources, right? And so I put on here, anyone who's ever, gone, oh, my website went down because I had an expired certificate. It was the day after I was supposed to renew it or whatever, and the infrastructure guys just didn't do it. And little things bring down the whole system, which is kind of a difficulty, right? But some organizations go, well, okay, I guess that's just the price of having a really big system, right? We'll sort of portray microservices as kind of maybe a different way of thinking about this and going, you know what, that certificate thing or whatever little bug was in that monolith shouldn't bring down the whole thing, right? We're going to sort of put out there that we want composable parts that if you knock one of them out, it doesn't bring everything down, right? We want a little bit of resilience in there. Monolithic apps, the fourth one, process boundaries. Monolithic apps, typically you're able to do whatever you want in the code, right? You can have global variables, you can have, or in a language like C#, you can have things that are just in your object hierarchy at the wrong spots. You can have these big giant objects that contain all sorts of state and are at the same time a state machine, an event pump. They do a lot of algorithms and have lots of functions that are helpers and things like that, but we can bundle them all together and deal with them from any place we want, right? We can do it from JavaScript up on the UI, or we can do it real close to the database, right? Monolithic systems kind of let us not have to deal with the complexity or a more pattern intensive architecture. And then finally, one of the things that also pushes against you, and I'm sort of phrasing this in the sense of you may be taking on your first microservices project, realize the people around you have an experience base that is based on big systems, right? Not necessarily what we'll talk about in terms of microservices here. CI/CD is all the rage, right? So continuous integration, continuous deployment out to different environments. Tough part is you kind of need someone in that DevOps space that understands how the development works, right, in order to do the ops piece, right? And so someone has to kind of bridge the gap there. And a lot of times that role is sometimes not present in an organization. So sometimes you find weird effects like infrastructure telling development how something is going to be built. And you go, well, it's not their skill set. And the development people, since they don't really understand how this pipeline works or how it gets stuff out there, so I have to go, well, okay, I guess that's just a constraint on my solution, right? So I've seen some of that behavior as well. And so just some things to think about, skill sets, some technical pieces here, and some design pieces that we care about. Now, that said, why are microservices also important? Oh, sorry. Make sure I have the chat window up here.
Hey, Brian.
Go ahead.
This is Joe. Shoot. Can you put that in presentation mode? Because the font's pretty small and you're showing it that way.
Oh, let me do that. Yes, let me see if I can do this. I'll probably have to drag it over to my other window. And I will do this. There. Is that better?
Yes, much better. Now I can read it.
Oh, hey, there we go. Okay.
Thank you.
Okay, I told you I had 600 slides, so it's good you caught me early. And I'll get Joe the deck here and everything, so you have PDF of all this stuff if you want. So I'll give you a few examples that have been out there kind of publicly for doing microservices, right? And in some cases, I wouldn't say that they have a silver bullet for everyone, right? You're not going to be able to take, like Netflix's example here, you can't take what they've done and just drop it into your project. But they give us some good design pointers and they show us how to do certain things. In many cases, we'll use the tools that are different from what these groups have used. And we may combine some of the parts a little differently. That's part of the art of doing microservices, but I think there's some really good lessons out there, and there are some organizations that have gone through microservices a little further than I have, and I sort of follow them to go, okay, what have they learned that I'm going to learn next week, right? That they can tell me today to avoid. And some of these I also put, not cost constrained. Some of these teams do have much larger budgets than normally you'd see. I would say Netflix started off as 100 developers, right? So that was not necessarily bad. Ford, I'm putting them up here as their connected vehicle program. That started off as about 300 folks. So they're not necessarily small teams or anything like that. But probably their biggest challenge was actually getting skills to be able to do this. It wasn't actually size of anything, right? You can do a small container environment fairly cheaply and have a project size of 2 to 5 people, not a problem. You can do the same techniques, I guess, that these organizations have done. I put Peloton up there. If you're familiar with the exercise bike, they are in AWS, so is Netflix, obviously. Ford is in Azure, Expedia is in Azure, and Spotify, I want to say they're in AWS as well. I should bring a GCP example in here as well to even the playing field and everything. So some of the things that when you see case studies out there from some of these groups, some of the transitions that they had to make, some of them were very people and human dynamics focused. So understanding how to do agile right. That is one of those things that I think a lot of us who've been on maybe one one project, you've sort of seen Agile once, right? It's not until we've done our 4th or 5th Agile project that you go, or maybe with different organizations or something like that, that you see it done a number of different ways and you're picking better practice. And you're going, I like what we did on that project, but there was one thing that really annoyed me, and so I've changed that on this current project. So understanding that intent of Agile, right? How do you coordinate within the team? How do you talk to each other? That's just a interpersonal thing. I would argue that's a component of good software architecture, period. Doesn't matter if we're doing microservices or not. But it's a difference from very specialized roles. And so even organizations that do Agile within the development shop may not do that in the project management group, right? You may still have a project manager, not a product manager. You may not have a DevOps team that has worked with an Agile dev team in the past, right? So there are going to be some of these things that you're going to have to square as we kind of push the bounds with this new microservices design and realize the microservices are going to challenge people in general. And then if you throw it into an organization that doesn't have its working relationship set, that can throw another wrench in the machine. Decoupling is absolutely important. So it's kind of interesting that Agile teams and microservices teams tend to be small. I don't think I've seen giant ones. They tend to be able to work fairly autonomously, but they do that because they are within the code base. We are decoupling from the other pieces, right? We're not building this monolith anymore. We're letting each sub-team, even if it is a large team, ship separately. So that's why I put in decoupling. That's kind of like the word behind microservices, if there was one. Generally, the challenge with microservices is you're going to be building a lot of little things, not a giant thing, right? The analogy of Lego bricks is probably pretty close here. So if you think of some of the, I don't know how many folks have like multi-thousand piece Lego sets or have built those with their kids or anything like that. Or as adults, I gotta say, I've pitched in a few times with my son a few times, probably more for my benefit than his. But building them out of the little 1x1 bricks rather than a fully assembled type subsystem, right? So we're gonna be building a lot of these small things, and that means that we can distribute it within the organization, but you have to have some patterns for people to follow, and you have to let these teams run independently of each other to some degree. The other piece that I would say that one of the bigger lessons from microservices deployments has been, in the past, I think we thought, and the reason I talk about it kind of in the context of a life cycle here, with incremental development or even just a large program, right? Maybe you're shipping on the best case every couple of weeks, maybe you're shipping every quarter or every month or something like that. The whole team has to be organized for that ship drill, right? And the idea behind the operational side of microservices is you are constantly shipping all these little pieces, right? And the environment that you have as a customer is going to aggregate those pieces. And when we talk about shift left or something like that, what that effectively means is developers are writing, building, checking in a build from my module. Okay, cool, and then I'm off to the next build. How those modules get assembled is the DevOps and operations and customer environments problem, not my problem as a developer. So that's where we sort of emphasize configuration over customization, right? We don't want to have this long requirement cycle before the development train. We want to give the developer something small like a single query, code it up, get it in tomorrow, right? And then the consumer of all this can pick the different versions of parts that they want and aggregate them together. So there's some buzzwords that we kind of have to get used to, and like infrastructure as code and things like that, shift left. So, okay. So I'll give you an example here. This is one that I'm working on right now. Try to illustrate some of these. I haven't really found a great way of doing this. There is a Plant UML plugin that does diagrams of our architecture here, but this is a payment system. And so we have a bunch of, we'll say, clients, applications that are going to call us to process payments. Just think of it as the little credit card reader in the middle there. Could be Google Pay, could be Apple Pay, could be any number of different things like that. Could be gift cards. We have a bunch of services deployed across the middle here. The reason I say there aren't really good drawing tools or anything like that. The only standardization for microservices is the little hexagon. I'm not quite sure if that's a thing or not, but so I put little hexagons for each of my services. And then on the bottom, we have support services themselves. We have a couple different storage mechanisms for persisting things. We have Kafka, we have logs and things like that that sort of support all of the microservices. But as a contrast to where the previous payment system was, and I'll just take this one customer here, there was one payment module. It was actually integrated into the POS, point of sale solution, right? Whether that's the website or whether that's the in-store point of sale piece, it was bolted in, right? And there was a lot of, shared variables and things like that. It wasn't the best sort of architecture. Parts of it were Visual Basic 6, which it's still in production. So I'm not gonna say anything about that. But the idea with our microservices was that we were going to have multiple of these, right? And we would have a very common path through here to actually process a payment, but you would probably call some of the other microservices to set that up, right? You might have to prime a device to take a credit card read, because when you go to process a payment, it's expecting that you already have that, right? So we sort of define a highly performant flow through the payments microservice here. That's the 1, 2, 3, 4 numbers. But there are a lot of other supporting microservices here that do other sorts of things, right? You see security off to the far right. You can see eventing and things like that. We take those off the critical path, right? So that we can have the actual payment flow itself, which is what this project is optimizing for, be as fast as possible, right? And we can also scale that out. So we have multiple instances of our payment, we'll call it an API. We'll have multiple instances of those. And then we can have all these other microservices sitting out there that people can use to help prepare their transaction, basically. Okay, so I want to give you kind of a real world view of this. So we are, I think, nine services right now, and we do those one-to-one with containers. Pretty much, except for the data layer, sorry. So down here on the Couchbase and SQL Express type stuff. And depending on which database we're using, those are they're special containers that we put in. But I just want to give you an idea of like the numbers of different builds that we go through. So we typically build each of these each day, or maybe a few times a day for some of them. And then they go into the test cycle, they go into CI/CD. Then they get deployed to whatever environments have asked for them, right? And realize the environment, there might be one environment, we'll say current point of sale would actually be a good one, goes, I want version 1 of each of these, right? It's a stable version, I know it's good, all my code is integrated with calling these particular calls. It has well-known performance characteristics. But the next generation point of sale, for instance, is like, we want the latest stuff, whatever that happens to be, right? So as a microservice, realize we just do a single function, but we're constantly revving and constantly giving out a new version. So our customers might not all be on the same version, right? So just wanted to sort of point that one out there. And we'll probably come back to this slide as people have questions, so I'll keep moving here. Talked about a couple of the things here in terms of scale, in terms of being able to do IoT type stuff. The key is to sort of skinny down our functions so that they fit within reasonable containers. And I'll sort of tell you what that means in just a few slides here. There's some other things that we like doing, and you'll notice in Netflix especially, things like A/B testing or graph-based compute, or maybe a mixed data structure on the back end. So there aren't too many applications now that don't have some tie-in. They don't just use relational storage. They may use document DBs. They may tie into a data warehouse for reporting or something like that. They're going to have multiple data storage pieces to them. Similar for A/B testing, that's really just having multiple types of compute footprint. And then the systems that we're able to build in these sort of domains have some attributes that microservices help fairly well, right? So for instance, the A/B testing, Netflix has a single service that when you log in as a subscriber, it puts you in a bucket and says you are in flight, you're in the Jackrabbit group or something like that. And Jackrabbit means that you get the latest version of these three things over here, but you get the stable build of these other microservices over here. And so it helps figure out your routing path for as you're logging in and how you get to see different types of features and different layouts on the screen. Microservices enable some of these more advanced types of scenarios. Okay. What are they? I don't know. I think I should probably just go do a demo right now. Why don't I do that? I'm going to top out to Visual Studio here. We're just going to go build one of these things, okay? You don't want to see Slack. You see that all day long. Oh, you don't want to see Teams. Let's get rid of these. Boy, now you probably want to see Visual Studio, right? Okay, let's get over here. Okay, so I'm going to start with this guy here, and you guys have seen this interface, right? So we'll just do a new project, and we're going to work in ASP.NET Core. It doesn't really matter too much, but I want to show you a little bit about the container environment, just because that'll tee up some of our comments here in the next section here. Primarily because we're moving from a single deployment vehicle to a much larger, much greater number of these. Okay, so we'll pick an ASP.NET Core app. Let's do that. Not too exciting. Let's call him Joe Kunks. Oh, I can't do apostrophe. First Docker app. How about that? We'll call it that. I'll just pick on Joe just because I know him. Here we'll do all this stuff. That's all great. We're just going to do the weather service, so nothing too tricky. So this is just the default one. We could do it from the command line if we wanted to. What we'll pick is we're going to pick an API. Of course, you got .NET Core out here. 3.1, I'm not going to work in 5.0 yet. And I'd be happy to know people's thoughts on 5.0 now that it's released and everything. So maybe towards the end, I'll sort of ask again and see what people think. One of the things we're going to do here is we're going to check this little box over here for enable Docker support. And you notice it requires Docker Desktop. So you have to download Windows Services for Linux and Docker Desktop. Fairly straightforward. I would tell you avoid 2.4. That's a few versions back now. Some of these have real problems with Windows 10, but I'm running Windows 10, what is it, the early adopter edition. So that keeps me with some of the versions that are supported here. A lot of the Docker support has come out on the most recent builds. Now, I can actually also pick down here Linux or Windows. I'm going to go ahead and pick Linux for now. I'll show you where that matters in just a second. So here we go. Make sure it's showing up on the screen. Okay, looks like it's showing up on the screen. I got 3 instances of Visual Studio running right now. Oh, come on. Can't fail on the first step. Come on, Bueller. Let's go. Maybe I gotta get out of some stuff. Okay. Of course, it pops up in the other window. I'll drag it over here. I don't get why when Visual Studio starts up, it just seems to randomly pick where it wants to start. Okay, so we have nothing too exciting here. If you look at startup's pretty straightforward. He has his usual stuff, configure services, configure, and our weather forecast. Oh, sorry, he's in the controllers. Let's go to the controllers. This is our API. We have a weather forecast controller. Woohoo! Now, across the top, we've got our handy drop down here. So I'm going to pick, first, we'll just go ahead and run it normally. This is, so folks who aren't familiar with the weather controller, it does everything in memory. It doesn't reach out to a database. It doesn't do any complicated logic. It just generates a bunch of random numbers and echoes them back to you. But let's go ahead and run it to make sure we can build it and everything. My dog, I want to let the dog out again. Okay, no, that's okay. She will be a perpetual part of this recording. Okay, here we go. Build succeeded. Come on. You can do it. Oh, of course, popping up the other monitor. So I'll bring these windows over as they show up. I'll give us our beautiful output here. We should have about 4 lines of stuff here. And almost there. Loaded all our .NET Core stuff. Only about 40 libraries. There's some new optimization things actually in .NET 5 that reduce the number of these that if they are not used, doesn't build your containers or even regular executables with all these guys. So looking forward to trying that out. Okay, here we go. And where's it popping up? Where is my, come on. You can see it's listing on localhost 5001. It is somewhere, but it showed up over here. Okay, I'll drag this over. Not too tremendously exciting here. So he gives me something like this. If I refresh, it'll give me some other random numbers. Fantastic. Okay, that's all out of the box stuff. That's nothing too exciting. Yeah, let's go kill that. Hi, thank you. Okay. Now, let's do it in a container, and I'll show you what containers look like here. Okay. Actually, I'm going to show you one thing first. So you'll see there's a Docker file in here that I put in your project because we checked that box up front. What this does is it has the instructions for how to build a container with your application. We haven't talked about containers much. Typically, a microservice will fit in one container. You can put multiple in a single container. On the project that I'm working on, we define the containers to have certain limits to them in the Kubernetes space. So usually they're 1/10 of a core. They also have 256 meg of memory, so not an awful lot. So we try and make them really small. And so right now we are doing one microservice to one container. The implication there is then we can get a certain density in our farm, and we're running our farm in Michigan, Virginia, as I mentioned. So we can deploy a lot of microservices into the farm, and then we can do some things with availability, duplicate services, and things like that in there from an infrastructure perspective that would be harder to do in code. So what the Docker file does is it basically gives us the instructions for how to build this guy. So I'm going to go ahead and I'll just kick off a build here. So I don't know how long it's going to take, but we'll just do a build, and we should see that pop out here in just a second. I'll see if I can scroll this up. So what this does, if you think of containers, they're not like virtual machines. They're a little bit more specific than that. If you think of them as different layers, and the base layer typically is kind of like an operating system or a stripped down operating system, right? So we have choices like the Windows Nano server, which is kind of ideal for .NET Core work, on up to full Windows images if you want that kind of functionality. Here we are using this first from statement. I'll sort of explain him for a second. He comes from the Microsoft Container Repository, that's MCR, and he is bringing in something that is called ASP.NET 3.1 Buster Slim. If I went out there to look up what that is, I think it's Debian Unix. It's either Debian or Ubuntu. I can't remember which. I have to go look at them. But Buster Slim is just the first one on the list. And then it says, okay, it is a Linux image with ASP.NET Core 3.1 on it. Okay, that's pretty cool. And actually 3.1, they have a couple flavors. So if you wanted to specify more specifically, you can do 3.1.8, 3.1.9, whatever it ends up being. You basically pick your, think of it as pizza maybe. That's the crust, right? We laid down the crust. And then we create a directory that we're going to pump our application into called /app. Remember, we're on Unix now, so all the slashes go the other way. And we're going to say, hey, he's going to be on port 80 and port 443. And then we're going to go build this darn thing. So in order to build it, Visual Studio actually does something kind of interesting. It off to the side says, actually, that crust that we're going to put the pizza on, we're not actually going to build on that crust. We're going to do another little crust over here that is the SDK version, right? And so we're going to get all the .NET tools and all that stuff that we're not going to actually have in that final piece of crust, the Buster Slim up top. The Buster image here with the full .NET SDK has all the tools in it, right? So it can do EF Core stuff, it can do all the pieces that we're interested in there. I can do all the scaffolding and other special Visual Studio commands that you'd have to have a Visual Studio development prompt for. Here, we're basically going to create a directory called source, and we're going to copy over our project. Great. We'll do a .NET restore on it, which does a build and, does a clean and then a build. Then what we're going to do is this kind of interesting thing here is we're going to take everything that's an output there, and we're going to copy it over. Oh, well, that's interesting. Then we're going to go ahead and try and build it again on our target machine using just the C# stuff. And then we're going to see if we can publish the darn thing. Okay, we're using regular publish down here, right? And then zip up all the pieces that we need. And then we're going to take that base image. See these tags like base here. And then we're going to say, hey, that's the final one. And in app, in that app directory, we're going to take from publish, which is the result of this step here, and we're going to put it in there. Right. Actually, we're going to put it in dot here. And then we're going to say when that container starts, he's going to start up with effectively, don't think of it as some sort of structured anything. Entry point just says run this command, and the command we're going to run is .NET something DLL, right? Which is going to fire up Kestrel in the container. Okay, so this guy, let's go ahead and I'm going to switch to that. Since we said we're going to do Docker stuff. Oh, wait, it's doing some stuff over here. What it's going to do is it's actually going to go ahead, and the default for Visual Studio is to pull any of these images that are containers that I want to use anywhere in my Docker file. It tries to pull those early so that you don't have to wait while you're doing them. So now I'll go ahead and run it. Let's see what the container tells me here. It's going to do the same build, but it's going to put it on this container. So I'll show you what that kind of looks like. And hopefully that'll give you enough of an impression of what, I guess in the past, we were used to probably like publishing as a web package or publishing to an IIS server or something like that. Here, we're going to publish our app and stick it in a container that could go somewhere like Docker Hub or could go to the Azure one. So let me go see, I'll pull up Docker Hub and I'll show you a couple of those while we're waiting here for a second. It shouldn't take this long, but anyhow, we just got a lot of stuff running. Well, I'll just show you Docker Hub already. Here we go. So Docker Hub is kind of a free place, and like a lot of services, you can do put 3 containers up there for free without having too much of a subscription. Come on, buddy. Let's go. See if you can show up here. So mine is BW Loomis. I put a lot of my stuff out there for free, but I have to keep going through and clean them up. So if I go in here, at the end of the publish process, if I did a Visual Studio publish to Docker, for instance, or publish to Azure, you'd see your container up here then, right? And so you'll see your container, in this case, latest is the tag that you apply to it. So like, okay, cool. And then if I want to bring that container into an environment, a Kubernetes environment, I'm basically going to, I'm going to do a Docker pull. If I want to put a new version up there, I do a Docker push, right? And then I could say, maybe I do a new compile, I do a Docker push, my account, and then I put a tag name at the end that might say latest, and I'll just overwrite the one that's up there. So they sort of have this idea of tags out here. So let's go ahead and see if our build is going, container warmup is going, okay. Now I'm going to show you what Docker desktop looks like. So our output gets a little more complicated here, which is why I say, I think when we're talking microservices, from a development perspective, we have to kind of learn a lot about these other environments and how stuff is getting deployed, even though that seems like it might be a DevOps role. It's going to be important because fundamentally when things don't work, right, and we have to debug them, we're probably going to want to run this stuff ourselves. So I'm going to show you, this is Docker desktop here. And when it comes up, it'll usually show a couple different, oh wow, this is really taking a long time. It'll show you all the containers that you're running on your local box, right? So Docker basically provides a container environment that sits on top of Windows. It actually uses Hyper-V under the covers. So everything that's on here is basically a Hyper-V container. It's a little different. Oh, something popped up, that's good. You can see that Visual Studio is trying to do something. What is it doing here? Come on. So I'll pick one that's actually running right now. When you hover over one of these guys that is a container, in this sense, just think of them effectively as, you know, we've packed the whole thing together. It is an operating system. Oh, there we go. It's starting to pop up. It'll tell you what port it's running on, for instance. So it does port mapping. So all of your local host ports translate just like when you're doing SSH or something like that. You do a port translation. So it'll run that web application, first one, 32.780 there. You get a couple cool things over here. You can pop it up in a browser. You can run CLI, command line interface. So I can shell into this guy. So I'll just, bring him over here. Pops up a SH window. Remember, we're on Linux. Again, let's see, Joe's is working yet. Joe's is running, so it popped up somewhere. I'll go ahead and I can go check that one. I'm gonna do that right now. And they have these really horrible GUIDs across the top. Oh, here we go. It's starting to give me some debug information over here. Okay, it's starting to run. Oh, no, took it away. Sorry. Okay, we'll go to the CLI for this guy. Well, that's working. And so it runs SH. You can set it to run bash or anything else you want, I guess. Remember, you're in Linux land, so JL or something like that. I got a lot of different things on this guy here. This is just a .NET Core deployment on a Linux box, so nothing too exciting. See what's running on this guy. Oh, nothing right now. No one's hitting that box. Okay. Okay, here we go. We're finally getting into debug mode here. Okay. Talk about some of the other pieces on Docker here. You can stop your service, right? Your container. You can restart it and you can throw it in the trash, right? Which frees up disk space because each of these takes a certain amount of time. But if I pick one, let's go ahead and pick one of these guys. It gives you sort of a details page. You can see logs. So in general, since microservices end up being stateless, we'll do things like running logs directly to console. We won't create a log file. Oh, sorry, here's our, let me pull this guy out. The website popped up just to show that it actually works. Yes, there's weather forecast. I'll just minimize him for now. So typically your logs will come into here. Many Kubernetes environments, Docker environments will basically aggregate all the logs off the different containers and pull them into a tool like a Splunk or something like that. Inspect them, you can actually see, for instance, environment variables that get passed in. So we're in dev mode for this one. So I'd expect it to be using ASP settings.development.json, things like that. They do set this one kind of interesting, .NET running in a container. Realize that you don't get all of these when you're actually in a real Unix environment. You get them because you're on a Windows box fundamentally. And then you can see how big your container is. And you can go, oh, this is what it's kind of using. So I can tell if I'm running on a Windows box, but I'm deploying to a Kubernetes environment that might be in a different data center. I can say what those limits should be. So here I go, okay, 100 megabytes or maybe 200 meg for my max memory would probably be fine, right? It probably wouldn't cause any performance problems. So these are going to be important as we get to deployment time. Okay, give you a quick tour here in Visual Studio 2. So you get a new window down here. You get a window. All of your containers are on the left side here. So we got these guys over here. I'll stay with Joe's first app. You can see environment variables there. Again, across the top, you've got stop, restart. You can do interactive debugging. If you go out and get the extension, there's an interesting extension out there called Bridge to Kubernetes that lets you debug part of a Kubernetes cluster. And by that, if we think of maybe a large number of microservices going out and working together, right? You may have, say you have 10 microservices deployed in 10 different containers. You go, I really actually only want to debug one of them. And what it does is it tells the Kubernetes cluster, don't fire up that particular container over there, route all the traffic to my local Windows box here for anything that's talking to that microservice. And so I can do regular Visual Studio debugging, leaving the rest of the containers all as they are, right, as they were deployed, right? And I can sort of walk through that. That's environment variables. You can see what port numbers were registered on. So remember we exposed 40 or 443 and 80. Those get mapped. So Docker does that mapping and tells Visual Studio, hey, this is really where you're listening on. Logs, if we have any, got a little bit, a lot. The interesting one here is files. So remember we built all this stuff and we put it in /app. Oh, I can actually look at this kind of like Windows Explorer and go, what actually got put on that box? Oh, okay, so I've got some stuff out here. I've got my files, great. And then I've got, of course, bin, debug, keep going. It's a .NET Core 3.1. I'm trying to remember what the exact one is. There we go, .NET Core app, right? And then we'll see all our stuff, right? Okay, so there's our great one there, is either the DLL or the exe. In our case, we said go ahead and run the DLL version. Cool, right? So that is what our website is running right now. And I could go in there and do a breakpoint like it. I might as well do that right now. Let's go to the controller. Now just put breakpoint in here for somewhere. Let's go to, is that good? That's good. Okay, let me go find my window. Where did he go? Bring up weather forecast. Refresh this guy. Beep. Visual Studio is beeping at me. Why? Yes, I know. So here we go. So I'm at my breakpoint. I get all my locals and all that kind of stuff if I want. And I'm just going to go ahead and do a continue off this guy and let him finish up. Okay, getting some new stuff out. So that's sort of the quick tour of building containers within here. Now, I'm going to show you one other thing before I get out of Visual Studio. So this is just one. right? This is just one API. It only has one method even, right? It only has a get. So that's not really a realistic one. So I'm going to show you a real project. And this one here has a number of different services that he runs. And in order to do multiple ones, you're going to use a tool called Docker Compose here. And what that does is it lets you do multiple Docker files, right? So you may have multiple APIs, each of which has their own Docker file, each of which has their own config and all the other stuff that they want. And you're basically going to right click on this guy here, and you can actually do this with any ASP.NET project. Core ones here, you go to add, and it is add. First off, you're going to do add Docker support, and add Docker support is going to put a Docker file in there, and then you're going to do add Docker Compose. And I'm not going to do those because that'll muck up this project, but the add Docker support is the first thing that shows up there, and he creates your Docker file. That's great. And you can see I've mucked around in this guy a little bit. The second one, once you've done that, then you can do add Docker Compose. Docker Compose does something also very interesting. So, sorry, creates another little project down here. But what he does is he does basically all the Docker files and says, how do I deploy a whole environment here? And you're going to get a new drop down here that says, oh, sorry, he's not my startup project. Let me set up startup. Set a startup project. And I'm not going to run this guy just yet, but what he does is he defines a group of services that are going to each have their own Docker file, or they're going to tell me exactly how they're built right here. And so one of them is my payment service here. And he basically says, okay, I'm going to build some image, DGPG payment service, and that's going to go out of this Docker file down here. So you can see where that source is. It says, go build that thing that's over there. Put them on this port, route that to port 80 in the container, right? So my service will come up on some random number here, 49502, and the container itself, my microservice, will answer on port 80. He doesn't have to do anything special. Now, he depends on another service, SQL data. Oh, where's that? Oh, that's right down here. I'm glad you asked. That one is specified in line here. So that is actually a SQL Server on Linux build. So that is SQL Server 2019. And you notice I put the latest tag on the end there. And then, so if I want to deploy basically a database along with my application, and then I specify some things like, here's my password and I accept the license agreement, blah, 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 and what port number I want him to come up on, right? That's great. So then the idea is that this guy, since he has a dependency, he depends just on SQL data too. I can actually refer to him in the app settings that way, and Docker or Kubernetes will route that directly. So let's go look at that connection string just to show you that there's not total craziness here. So actually, here's the one I would normally use for this is SQL data 2, comma 1433. Remember, it's port 1433 is what we're mapping to. I have a database called this, pass in a username. Tough part is it doesn't synchronize this password with the one that's over in that Docker Compose file. So you got to type it in a couple places or keep it as a secret somehow. And so you can see I have a lot of other different connections here, but when I'm running local Docker, I'm going to use that one. And so that's sort of Docker Compose there. And let me see. I don't know if I want to do this. Do I want to do this? I'm not really running very quickly right now. Let me get it going and then I'll come back to it. How about that? I'll just jump back over to the charts. Any questions on sort of the demo here at this point? This is good stuff. You guys go, oh, containers, that's not too hard. No? Okay, I'll take that as a yes. Let's get back. Where we go? Okay, here we go.
So you didn't hear me shaking my head yes?
Oh yeah, I know exactly. Your hair was on fire. You're like, wow, this is awesome.
It is awesome. I'll speak for the group. It is awesome. Thank you very much.
Yeah. No, it's interesting stuff. And so I'll come back over here while that stuff's firing up, and then we'll come back to it. We've got a couple more minutes here, and let's see if I can wrap some of these sort of ideas up. So the what part of this talk is, I guess, as you're taking on a microservices project, I guess, things that I guess I wish I'd known. One, you design things a little differently, right? When we talk about microservices, sort of the common hit list is sort of some of these things. Microservices are small, right? They're called micro for a reason. Shouldn't be thousands of lines of code. Probably should be in the hundreds, possibly even smaller, right? Single purpose, right? They deal with one thing, maybe an entity in the system, maybe it's a single database table, something like that. We talk about that as data sovereignty as well. And so this is the sort of the idea of one API deals with one database table. Not always as easily done as it's said, but that's sort of the idea, is that one way to keep them small is to have sort of a master data access layer API, if you think of it that way, for each table, right? So you may have multiple of these data access layer pieces. Don't want to have a lot of external dependencies, not a lot of coupling. If you have maybe one or two things that you talk to, that's plenty, right? You don't want to be talking to 10 things, because then likely your code is starting to branch and you're starting to have if this, then that, and starting to have else to error conditions, and you're rebuilding that monolith, right? But we talk about high cohesion as opposed to low coupling, right? Low coupling means I'm not tied to too many other things. High cohesion means all the parts are in the box, though. So if I'm talking to, for instance, on the payment side, that credit card reader, all the credit card reader all the credit card reader functions should all be in that one module, right? Unless there's a reason not to. A lot of times we're dealing with different types of calls into the API. You may use media types or something like that. In IoT space, you might use AMQP. If you are a normal web API, it's HTTP, REST, and JSON, okay? The other thing is that we kind of want to have kind of a dumb network layer that just routes things around, right? It doesn't do any transforms or anything like that, and have our endpoints, our modules, be the smarts, right? So all the smarts is in our DLL, our microservice, right? And then the other one is being stateless, right? So again, we're coming back to this idea that the microservice should probably not keep too much state. Doesn't mean you can't do caching, but generally we're trying to design for the case where the microservice could be blown up for whatever reason, and Kubernetes, the environment, could restart one and it would just pick up where it left off, right? We want to design for that kind of fault tolerance, right? Because remember, one of our types of projects was sort of high availability. So stateless is important. Okay. Lots of technologies around this. So one of the other things, so we talk about development principles, how do we sort of size and scope the microservices? The other piece is there are a lot more tools involved here. You saw just even in my demo, we had Docker in there, we had Visual Studio in there, eventually have Kubernetes in there. Oh wait, I have to deal with Jenkins on a daily basis and make sure that that works the right way. Lots of test tools get bundled into CI/CD and DevOps there. On the infrastructure side, when you get out to the environment, you're going to be learning Kubernetes commands and kube control and things like that. You may have to register your API and API gateway. And for folks that have gone down the SOA route, you're like, oh yeah, we always sort of talked about that. We never really got much buy-in. API gateways, Apogee, as the Gartner Magic Quadrant on the right there. A number of these are out there, and organizations that have a lot of microservices need to have a way to discover them, right? So it's kind of what we thought of in SOA, but now we're breaking it up into so many small chunks that there's no way you could do it without a tool to help you there. And then realize, of course, you've got the usual security stuff when you deploy. Interesting change here, I think, from an application design perspective. We've always thought, oh, well, we've got to code HTTPS, we've got to code certificates, we've got to code passwords and all that kind of stuff. I'll give you the example in that Docker Compose situation there where we're deploying a couple different services, a couple different containers. The container environment does a lot of this now. So the app designer, I build microservices that only listen on port 80. I don't deal with all the security stuff. That gets layered in as I go through that DevOps pipeline. And once I get out to Kubernetes, so that app settings, where I might have had that database password, that app settings gets overridden by, even in Visual Studio, a Docker override file. Once I get out to Kubernetes, I have Helm charts that overlay that and say, ignore whatever's in app settings. I'm going to give you the password. And what's more is I'm going to give you the password for production that's out of a HashiCorp vault or some sort of secret storage mechanism that the application doesn't even know about. And so you can decouple all of that security stuff from the application development itself. Now, that means, sounds like more roles on the team. Sounds like your DevOps and your infrastructure people have to be pretty good. Yes, probably, right? They're going to have to learn some new stuff too. Okay. Okay, keep going through this. Designing for resilience. So we talked a little bit about that. I think a lot of us sort of do evolutionary design or evolutionary architecture at this point, meaning we try not to do big design up front. But availability, performance, some of those require kind of deep dives, right? And so we have to plan for system failures and have responses to that, right? It might be compensating transactions, might be additional types of testing, chaos testing, might be, I put up here a couple of these, TRIZ is one from the former Soviet Union and sort of a systems methodology, which I think is kind of funny. And then there's a guy over in Sweden, Barry O'Reilly, who's written a lot about complexity theory and possibly something for to look into as we look at building highly resilient systems. So there are a lot of different places to look at for that. I would say the architect spends a lot of their time dealing with this rather than the what actually gets built. And just for your fun theory for the day, a lot of this gets back to, especially when we're dealing with resilience, the Cap Theorem, which says that you can pick two, right, of these. You can't pick all three of these. And so you see this in even in message passing architectures. Many of these microservices, things use Kafka or RabbitMQ or something like that, but all of them have limits that are still based on this, that you can, it's kind of like the Heisenberg uncertainty principle for software, I guess. Understanding with a distributed system what the current state actually is for a given transaction. So the key is then to sort of, as an architect, go, okay, what are the important parts of this? Which one can I trade off and not deal with? Most often, what people trade off is either, let's see, usually consistency, which means that with a real-time system, you have stuff streaming in all the time, right? And you know that there are going to be data dropouts on that stream. Not that things necessarily come in out of order, but you put the burden back on the client to keep checking for what the latest stuff is, right? So that if for whatever reason my service goes down and I have to take a little time to rebuild that service, you'll be able to call me at some point and get a good status, right? It may not be immediate, but in most of these sort of real-time systems, we will give you the correct answer, which is that available answer, if we have it. If we don't have an available answer, it means something went wrong and we're recovering from that, and we'll get back to that available answer. But the client should have to maybe keep checking for certain things, which is, I guess I'd say, the practical implication of that. Think of Netflix. Every now and then the picture goes away, right? But it catches up, right? Somehow your movie goes, it just has like a glitch or something like that. And the stream keeps coming, right? And though you may have lost a couple packets in the middle there, it couldn't render a couple frames. That's okay, right? Oh, I'm not in presenting mode, am I, anymore? Let me get back to that. That's rude of me, I think. Here we go. Sorry, I'm gonna come right back. Oh, and by the way, my other service popped up, and I'll show you that in a second here. Okay. Let's see. Here's the picture I probably wanted to show you earlier. This is out of the Microsoft book that Cesar de la Torre wrote. Some of the recommendations for these guys. So the little picture sort of shows how you compose these services. They can be different in different parts of the cluster, right? They don't all have to be the same virtual machine everywhere, or the same monolithic app everywhere, right? Remember to keep refactoring stuff, keep trying to get down to smaller and smaller containers. I would say that's a cultural thing. Many of us, once we've built a certain set of code, are very reluctant to change that code and realize that this drive towards microservices means that if I have large chunks of code, I want to keep blowing those up and making them smaller. And all the little small ones, I want to deploy them all separately from each other, right? To decouple everything from itself. So just that refactoring sort of mantra, and people just by nature will resist that, right? Because it's, I gotta go back into that module and I gotta rebuild it again, basically, right? I gotta rethink that whole logic train. Start with APIs first. Trying to think of other things that are in here. Use common protocols. You don't know who your client's necessarily going to be, right? Because we are deploying to an environment, and that environment is going to pick and choose which containers they want. Not necessarily me building this all up packaged product. Okay, let's keep going on this one. Oh, actually, go back one. There's one thing I wanted to mention on here. There we go. Asynchronous message passing. So microservices in a lot of ways do rely on asynchronous stuff, which means having some sort of persistent storage to track messages, right? We don't want that storage doing an awful lot. So we don't want, for instance, if it's SQL Server, we don't want stored procs in there. We don't want jobs and things like that. It's just a dumb repository. It's a place for me to write stuff down so that I can persist across a failure on the compute side. But that also may mean a Kafka or a RabbitMQ or Confluent or something like that. This switch to asynchronous, though, kind of throws a lot of people too, right? So we got to learn how to develop services that you make a call to my API. I'm going to return right away, no problem. I'm not going to block you, but I'm going to send you a stream of events back. How do I get those events back to you as a client? Do you have some sort of maybe a webhook? Do you have a maybe you're reading a Kafka queue yourself, whatever it ends up being, right? We have to think of those mechanisms, right? Because we're not using APIs the way that they sort of first started out and so on. Some other risky areas, I guess I've learned, some of your tools that you may have used before, SQL Server in specific, doesn't do the kind of stuff that you want it to do. I'll give you the example. So I mentioned a lot of our containers are 1/10 of the CPU. The SQL Server container is like a monster and has to be in its own little pod by itself. It covers, it's I think 5 gigabytes or something like that, and it's got all sorts of threads inside it and things like that that are always running. It is probably not the database choice we're going to end up on. We will probably move to something that's a little more lightweight and also distributed as a database. We have been looking at Couchbase and Mongo and Cassandra and things like that. So there's some of those things that you go, certainly as the designer, you want to look at each of those technologies and go, okay, is that going to be the right one to fit my sort of microservices approach here? Even if your team knows microservices, everyone around you may not, right? So you have to socialize a lot of these ideas and give people examples and sort of help build it up a little bit. Business process, breaking big rocks into little rocks. It's a lot of re-envisioning things, right? It's not just tweaking code, and a lot of your business sponsors, the people that are bringing you requirements, may not want to really go and redo all those requirements in sort of a new way, right? You're going to have to talk to them about what the benefits of this new approach are. In my case, the value of this payment system is that it's had a lot of outages in the past. And so availability and performance are two key requirements. And so usually I phrase microservices as helping design a system that'll meet those and help solve the pressing problem that they were having with the previous system. There are a lot of very immature technologies out there. So just realize how much risk you're taking on with tying different things together. Docker for Visual Studio is actually, I would say, fairly solid, seems to do pretty well. There still are bugs in there, but generally you have a community of people that support you on that. But there are there's a new product every week on these sorts of things. And so just don't take on too many of those all at once. I actually saw the statement in Red the other day that someone was estimating that 85% of the systems that are out there are effectively legacy debt at this point, or at the point where they are basically so big that it would be hard to do a strangler pattern or something like that, be able to break them up in a way that's either cost effective or would finish within the next 10 years, right? They're almost paralyzed, right? They're that big. And so realize that you as the designer of maybe the next gen system, if you're doing microservices, make sure you set the bar at, probably replacing that whole system, right? Don't think it's a phase 1, phase 2, phase 3, phase 20 sort of thing. Don't shy away from, if that system is really getting old in the tooth. I mentioned one of the point of sales was Visual Basic 6. I'm like, it's got to go. I can't finish this project and not have gotten rid of that, right? So take it on. It's your project, and take on the big challenge if you have. Okay, skip that guy. Put a few references out here. There are 2 great books on the Microsoft side. They're PDFs, I guess. No one reads books anymore. We just read things on our screens. Put Amazon out there, a couple bits on Netflix. Martin Fowler's original, I guess, site, he's collected a number of different articles over the years on microservices. It's definitely an art and a science. It's going to be one of those things that's definitely a challenge for developers to sort of grow into and do things a new way. So hopefully you take that away from this talk here. I'm going to do a quick check-in here, but if folks have any questions, let me go check in on my Docker containers here. I'll bring those guys over. There we go. So you can see we have a Docker compose that basically put out there SQL data 2 is my first one, and then my payment service is my second one. And again, it puts out the port numbers. I can go browse to these guys. Just show you, actually, I'm gonna have to scroll down a little bit here. I don't want to do too much, give anything away. There we go. So we use Swagger for all of our interfaces here, and basically gives you, so for like rebooting a payment device or something like that, I can try it out. I don't know if you guys have seen Swagger before. Really useful. And I'm trying to think what a good device is. Should pick one where I have a store, actually. They know what stores in the database. Oh, I have the wrong connection string. I'm not going to hook up to anything. Sorry. You saw I had that as the old default Docker string. And so we built it with another one that actually points to our container space. Sorry. Oh, well. That's the other thing is you want to change a connection string. Go ahead and rebuild. Redeploy. A lot faster in our cluster, but it's not as fast on my laptop. So I'll leave it there. If anyone has questions on different things, you want me to go back to different parts of the slides, talk about particular topics, happy to. Hope this was helpful for folks to sort of get a first view of how we do microservices, how we get them out in container space, and what they look like.
This is Joe. Just a reminder, in the chat, I have put the link for the speaker evaluation. I would encourage you to please complete that so that Brian gets some feedback on this presentation. I'm sure he'll appreciate that. We're always looking for opportunities to improve in our code as well as our presentations. And then I will leave the recording going for questions regarding the presentation. And once those questions are done, if we have any, I will stop the recording and then we can go to general discussion, which won't be recorded. So does anyone have any questions for Brian before I stop the recording that are relevant to the presentation? Going once, going twice. Sold. I'll stop the recording.
This conference will now be recorded.
Very good. So Prasad had a question. Suppose you have a .NET Core app deployed in the cloud somewhere, and it's importing files potentially and saving those, like a CSV or something like that. Should you leave those in the container, maybe the Docker container, or should you push them out to like an S3 bucket, which is Amazon storage, right? So my first answer would be yes, push them out to a persisted volume somewhere, right? So when you define your containers, if I went into the Helm charts, because Visual Studio does design some of the Kubernetes Helm charts for you. When you design a container to go into Kubernetes, either PKS or Amazon or Azure Container Service, you specify whether it uses persistent or ephemeral storage. And ephemeral storage means that whole thing can be scraped off and just goes away, right? It could just vanish in an instant. For those type of containers, that's typically where we're logging to the console and standard out, and then pulling those directly into Splunk with an agent or something, right? So there's no storage on that stateless container when he's ephemeral. He does have a little bit of scratch space of disk basically to work with, or if it's small enough, it might just stay in memory. But the persistent storage ones are the ones that you typically architect for just this purpose. And oh, no problem, Prasad. Yeah. Prasad's saying he's got a sleeping kid too, so he doesn't want to wake him up, and so he wanted to type this question in. The persistent storage ones are going to be either containers with dedicated disk space to them, right? So meaning that disk will persist between when that container gets blown up and restarted, any of that kind of stuff. Similarly to S3, right? Which is actually why AWS separates their compute from their storage, right? Is that then you can sort of mix and match that way. And so that's the right way to do it, is to probably use the either a persistent volume that they give you, or create a container. In the case of ours, we have a SQL server that has persistent storage, which is also one of the reasons it's so big. But yes, keep the persistent data in a persistent container. Yep. Cool. Yeah, thanks for the question there. That was a good one.
Yeah, I appreciate it as well. Any other questions? I think you've overloaded our brains, Brian.
Oh my goodness, yes. Well, I want you all on my next microservice project with me, so okay.
There you go. Share the joy and or pain. I'll just make an observation before we wrap up.
Yeah.
Brian, I've been to a number of presentations where they really focused on the how. What I really liked about how you approached it was you really shared your experience, and you talked a lot more about the whys and the impacts and the decisions that need to be made. And for that, I really appreciate that.
Sure, absolutely, absolutely.